up afterwards. And there's a very good structural reason for this, and so we'll just keep using it. The reason is because of if an error happens in your program, all the variables on the stack get kind of clean up after themselves, and so if you have a destructor, the destructor gets called, and so it will automatically reclaim the memory. You will pay attention. All right. He was smirking, and I wasn't sure if it was just the ridiculousness of wearing a robe while teaching. Okay. Okay, so let's recall this iString stream. And remember, if we want to just convert a single set of digits to an int type, or if we want to convert an int value into a set of digits, there are two functions from the standard library. I believe these are new in C++ 11. There are two functions that we looked at last time. One of them was s to I, or in other words, string to int. And the other one was this function called toString. And these are part of the standard library, and they let you go back and forth. Okay? But then at the end, we also said, OK, well, let's say you have a collection of characters or numerical values, let's say from a file. Then the iString stream and OString stream allow you to read and write to a file. Okay? So when I was a young Padawan, a Jedi Master came to me and said, I have a file with XYZ three-dimensional data. You will load in the file. You will extract the coordinates of these data points, and you will run a ray tracing algorithm through this lens. And so one of the very first things that I did was I had to learn, OK, how do I take a text file organized in, say, a table format with an XYZ, new return, or new line XYZ. How do I load that into a vector, for example, or a vector of vectors? Okay, and then I can do my numerical calculations once I have access to that. Okay, so that is a true story, except the Jedi Master was actually a professor and I was an undergrad. Okay, so let's create a file. Call it so 1, 2, 3, 2, 3, 4, 3, 4, 5. Okay, we'll call this my. Whoa. Okay, looks like some things got moved around. That's fine. Let's put it in 10b. 10b, and here we go. We're going to call this my. Just call it table data. Okay, there's my table data. And so what I want to do is I want to load in from a file each of these lines one at a time and then run it through my string stream. Okay, so remember the code from lecture 7. Here's our file I/O, right? File I/O looks something like this. Oops, that's fine. File I/O looks like this. We have an if stream object input data, which grabs the location of a file and then gives you the ability to grab values from it just like it was cin. Okay? Just like it was cin. Now, we're going to do something slightly different, which is we're going to do the following. Rather than do something like if stream input file table data.txt, right? Rather than doing something like this, what I'm going to do is, so every time we create a file, we have to test to make sure that it opened properly. And so we really don't want to do this each time. Here we go. We don't want to do this each time. So what we can do is let's create a class object designed to mimic an input file type functionality. And then we can overload various operators in order to make it look and feel exactly like cin and cout. Okay? So that's the idea, and let me show you how we're going to do this. So let's create a class called input file. Or let's see, maybe call it read from file. That makes it a little more apparent what we're doing. So we're going to have a private variable, which is going to be a if stream or input stream object. We're going to just call this fin. Okay. Now the constructor for read from file, that let's demand that we always give it a text file initially. Okay, so let's say we require something like a const string reference file name. Okay, now when we define this, what we're going to do is we're going to initialize the input data, what is it called? No, fin. Yeah, we're going to initialize fin using that file name. OK, build succeeded. OK, so what we're trying to do is set up a class object which behaves exactly in the same fashion as an ifstream object. And so that way what we can do is we can start off by loading in the file. And then the next step is always, always, always to check if the file was opened properly. Okay? So we do the if fin.fail, cout couldn't open file. OK. All right. All right, now what do we want to do? We want to be able to do something like the following. So we need to check, right? So we do if input file.fail, then cout couldn't open file. So let's just see if it found the file or not. OK, it found the file. All right, so the file's there. Now we want to access it. Now, there is a really nice function called what to get an entire line of text? GetLine. OK, so let's call getLine on in. What do you usually put into getLine's first parameter? Cin. But as I keep telling you, right, it's set up so that it could be a console object, a console cin, or a file input, or a iString stream input. Okay, this is the utility of, and this is the principle of polymorphism at work. We've only defined the operation for a type of object in a base class of, and we've only defined it for a certain type of object. And as long as our other classes contain that as its base class, we can utilize that functionality as well. We don't have to do anything extra. So we do getLine input file, and we need to give it a name of a string. So let's just call it s. Or let's just say row. Okay. Now let's just cout row. Make sure we're not going crazy. Ah, there's my row. Okay? But it's in a string form, right? It's a string. Now, let's see. What would we want to do next? Well, before we forget, we should probably do input file.close at the end, just to make sure we clean up after ourselves. Okay? Now, how do we extract each of the numerical quantities from this string consisting of a rather nicely formatted set of 3 numerical values? Hint, we make an iString stream out of it. Okay, so we create an iString stream object, and what this is saying is, give me a collection of characters stored in, for example, a string variable, which is what we've done. Okay, so we gave it a row, which is a string variable. Row is the result of the getLine. Okay, now what we've done is, let's see, there is no temp defined, but str is going to be exactly like cin. And it is as if we had inputted 1 space 2 space 3 enter from the console. So let's create a temporary int temp equals 0. Let's create maybe a vector of ints, call it v. OK, we do this, and then we print them out one at a time. Same as last time. Oops. OK, so we start out with a string, 1, 2, 3, and then we have the numbers 1, 2, 3, each individually stored as an int data type. Again, this first line is the result of printing out a string. Okay? And what we're saying is because that string is formatted just like console input would be formatted, we can extract the individual numerical values one at a time. Now we just need to loopify this, right? We need to get all the values from the table. So let's stop for a moment and let's ask ourselves the following very important question, which is, in essence, what is the one thing that we did with this code? Describe in one statement what the purpose of this kind of gobbledygook set of code was to do. Yeah, convert a row of strings, or of characters in a string, and extract the numerical values and store it in a vector. Okay? One idea, one line of code. Let's try to make it one idea, one line of code. All right? So this is where the class object structure comes into play. All right? So we can write this code like this, right? But, I mean, do you think you'd be able to read this in a week? Maybe, maybe. But let's make it beautiful. Let's make it such that you don't even need to know that much C++ in order to really understand what's going on here. Okay? So first, let's make sure we have a good input file. So let's replace the ifstream object with the object that we've created, this class we've created, which is a read from file. And let's call it fin. That might be a little confusing, so let's call it file, table data.txt. Now, in the constructor for the read from file object, it's going to do the check for the whether or not it could open the file. Okay? So just by constructing an object from that class, we've gotten rid of these two auxiliary lines of code. Okay? We replaced 2 with 1. In addition, we don't need this input file.close because the destructor automatically closes. Oh, wait, we should probably put that in. This is what I intended. Read from file. Here's our destructor. We're going to have this automatically call fin.close. And we've now gotten rid of 2 lines of code. Okay, we got rid of the input file.close. Okay, so far so good. So let me put this down below. Okay. Now, how do we get a line from the file? You will wipe that smirk off your face. Okay. So we want to work entirely not with stream objects, but with this class object that we've defined. Okay? So what we want to do is mimic the functionality of getLine, right? But for our class object. So let's write our own getLine function, which accepts, actually this is bool, getLine. It's going to accept an object of type read from file. And we're not going to make a copy of it. We're just going to have a reference. And then we're going to need to pass in a string reference. Okay? So let's go down below. And all this is going to do, this is a non-member function, okay? So it's a non-member function. Here we go, file. all getLine is going to do is pass along the call to getLine to what? The stream object, like so. And what we ended up with is cannot access private variable. OK, that's true. How do I? Oh, yeah. How do I fix this? I'm going to make this a friend. OK, and that's something different now. OK, so now what I can do is call getLine on file row. Now it works. Oh, wait. Forcing value to bool. Oh, I need, OK. Actually, I don't return getLine. I return, don't I? Well, I need to return. Oh, getLine is actually void. Yeah. OK, never mind. getLine is not bool. getLine is void. OK, there we go. OK, so now what we're doing is we're calling getLine on our class object, passing in a string row. And now let's see if this actually works. Oops. Still works. OK? So what we've managed to do was condense this whole structure associated with input files, this call to an open, this check to make sure it's a valid file, a .close at the end, and we've condensed it just by creating another class ourselves which contains this set of code in its constructor and destructor. The reason this is useful is because if you want to open up a bunch of different files at the same time, you really need to check every single one to see if it got opened correctly. You really need to call .close on every single one. When you do it this way, you can create as many file objects as you want. All of that stuff gets taken care of automatically. Okay? More importantly, we get to add more customized behavior because we have a class object that we can overload functions and operators on. Yeah, question?
Do you have to put getLine outside of the class as well as inside of the class, right?
I don't think so. Let's see. Probably not. Yeah, no, you don't. Yeah, good question, good question. OK, now should we tidy up this next part? Here's the better question. Rather than calling getLine, which is a great general purpose function which grabs the string, let's say, for example, I knew that I was only ever going to be reading numerical tabular data from a file. Rather than calling getLine on my file object and a string, I might want to pass in the file object and a vector directly. Okay? In other words, if you want to access large amounts of numerical data, you probably don't want to think each time about, OK, extract the string, and then convert the string using an iString stream into a separate set of numerical data. You want to go directly from the line of text on the file, or the idea of getting the line, and not getting it as a string, but getting it as a vector of numerical values. Okay? So that's the idea. So let's do that. Let's make that happen. And this is the idea of this is why we create our own class to do it. Okay? So we want to do, instead of, we've managed to replace a lot of code so far, but let's finally replace the rest of it. So rather than calling getLine like that, let's create a vector of ints, v, and let's call getLine on file, v. That's what we want. That's really what we want. Okay? So let's make this happen. So we have getLine for a string if we ever needed it. That's fine. But now let's make one for a vector of ints reference. Okay? And we're going to assume it has no elements in it. That's a very important assumption, because we're going to be calling pushback all the time. Okay, so we go down below here. Here's a getLine. And in fact, instead of calling it getLine, what might be a better name for it? GetVector, or maybe getRow? How many would prefer getVector? How about getRow? You will all agree with getRow. Okay. We're going to go with getRow. Okay. Now we do a vector of ints, v, and then we're going to basically copy and paste the code that we had in main in here. So all this work we've done so far to understanding these individual topics is great. We can utilize them in main if we want, but the more optimal way to do this is to use this in a class structure so that you only think about it once, you only write the code once, and then you let the class itself do everything else for you. Yeah?
So when you chose to make the read from file class, why didn't you, like, as an alternative design, why wouldn't you make it, for example, a subclass of ifstream and then, like, tack on functions to that? Like, what choices between those two? So instead of encapsulating one, like, the way, like, you just did, like, why wouldn't you make it a subclass?
Oh, very good question. I think what you mean is why didn't I make read from file inheriting from the if stream or whatever version of that class? Okay. Two reasons. One, the general rule of thumb is you don't want to inherit from any class in the standard library. I think that's a safe assumption. I know it's true for vectors. You never, ever, ever want to inherit from the vector class, from the standard vector class. I'm pretty sure it goes across the board as well. The other reason is because it doesn't really satisfy the is-a property. You can kind of make it work, but the idea is that this class object is not meant to be the file stream itself. It is not a file stream itself. It is merely it contains a file stream, but it is meant more to sort of wrap around and nurture the file stream and kind of be a support for the file stream object. But it's not meant to be seen as a file stream object itself. It's not itself that. So that's the kind of abstract answer. The real practical answer is you shouldn't be inheriting from these standard library classes anyway. Yeah, but that's a good question. I mean, why not just inherit from it and you get everything for free? There's actually, so knowing that abstractly you want to design it this way, there's actually a really cool line of code or function you can write that lets you basically pass everything to the file stream object so that it behaves almost identically using the less than operator. So if we have time, we'll get to that. But excellent question. But let me continue on with this idea of we want to extract a row, store it into a vector, and we don't want to think about any of the intermediate steps in the process. Okay? So again, we want to be able to just write. We don't even want this string row. We want to write, file vector get row, and then magically v is going to have all of the elements in that next row in the file. Okay? So let's make that happen. So let's take this iString stream and let's put it in this getRow function. So we have our iString stream object. It's going to need to get a set of strings from the file. So we're going to call getLine on file, and then let's call it row. So this is where our string row is going to end up. We're going to create an iString stream object based on the line of characters that row was given from the file. And then instead of creating our temporary vector v, we have a vector v. And we're going to keep pushing back as long as the iString stream has elements to give to the vector. And once this is done, now what should the vector v contain? All three elements. And it doesn't matter if it's 3 elements or 20 elements, it will go through the entire row, which is exactly what we want. So let's see if this works. Let's get rid of this row. Oops, this one. And there we have it. Okay? So the vector v ended up getting all of those values. So in other words, now what I can do is, let me get rid of all this code. Just check this out. Look, you call this, let's get rid of this, put this down below. How easy is this to read? You literally have 3 lines of code, which says, if I'm going to read from a file some set of table numerical values, I call get row. All of a sudden now my vector v has the elements that I want. Now, what if I call row a couple more times? What's going to happen? It's just going to keep pushing them back. Okay? It's going to grab the next row, extract those values, and because we're calling pushback, we're just going to keep growing the vector one call at a time. Okay? So in this respect, we can continue to do this until, I wonder what happens. I forgot if there's a guard here. Well, it works till 12, and then see. OK, so it'll keep going until you get the entire contents of the file. And you can check to see if the file has ended or not. OK? So the advantage here is that you get to operator overload or function overload on the object that you created yourself. And now you have complete unfettered access to the data. And you can take these smaller, very tedious tasks and condense them into a single task. OK? That's the idea. Matrix file, go to code. OK. Now, this is all fine and dandy. Let's see. OK, so if in your homework assignment you have to read and write from a file, say coefficients from a polynomial, and to output polynomial values, you create the class objects for an input file and also an output file as well. So we have a read from file, and then we have a output to file class as well. And we can do the exact same thing. We can say, OK, privately we're going to contain an OF stream object, call it fout. And what we're going to want to do is output to file. We're going to have the name from a file is going to be, say, const string reference file name. We're going to have a destructor. And then, ponder this. How would we write to a file? What should the code look like to write to a file? OK, so let's say I get this data, and now instead of saying just printing out all the values in X, let's say I want to just transform them. So here's a cool thing. Remember this auto keyword I showed you? it loops through all the elements in the vector. Well, if I do just auto x, it stores a copy of the value in x and just prints out the copy. If I want to access the actual value itself, I do auto reference. Now any changes I make to x are going to be registered in the actual container v. So if I do, for example, x times equals x, so I square everything, then I do auto x in v. Oh wait, no, I'm going to print it out anyway. Well, let's print it out separately. Okay? Let's say instead of just printing them out and grabbing the value, I want to actually modify their contents to square each and every one of them. Then I need the auto reference, because the auto reference will say, grab the actual contents in memory, square that, and store that value. Without the reference, it just makes a copy of the value and stores that value in x. Okay? So I square all the values, and I print them out in the next line. Okay? So back to my original question, which is, C-outing is nice, right? You see the console output, you see what the result of the calculations were. What would you want to do if you wanted to write to a file? How would you want that code to look? I'll be right here. Take your time. Okay, so what we want to do is, right, we want to take the example that I gave earlier, which was the input file. We want it to mimic cin, right? So now, how do we get it to mimic cout? We use the less than all the time, right? Okay, so let's write the code first. This is what I want to try to get you in the habit of thinking. Write the code first. We want to write to file. Call it, say, squared data. Okay, so let's call it table squared data. Wait, what did I call my? Oh, output to file. Okay. Now, what code would we love to write to be able to just write those values to the file? How about something like this? Or how about this? Don't even try and overload the output for vector. Try doing the following. Replace cout with output file. In fact, let's just call this fout. That seems about right. Instead of outputting to the console, we want to output to the file we've created. Okay? So now how do we do this? Yeah, overload the less than operator. Okay? This is why we did operator overloading first, even though it's in chapter 14 in your book. It's because there are some very nice practical applications of operator overloading that can transform your code into a bunch of sort of random components pieced together into a really nice cohesive unit which makes reading and writing code much more enjoyable. Okay? So, okay, how do we overload the less than operator? First of all, do we make it a member or non-member? So usually I have you guys make it a non-member friend. So let's do that. Okay, that sounds like a good idea. Let's not rock the boat. Okay, so here we go. Friend. What's it going to return? Yeah, a reference to the class, right? So the standard one is the OStream reference, right? But we're not working with the OStream objects themselves. We're working with the output to file class. We want the output to file class to sort of replace the use of streams. Okay? So we do output to file, operator less than, and we have an output to file reference. And then what type of values are we going to be piping to the file? Let's just say int. Okay? So do this. Go down here. All right, now we have to name the file. Let's just call it fout to make it easier to interface. Int, let's call it a. Now, if we were going to overload like cout, what would we write? We would write return cout a, right? Something like this. So, but instead of cout, what are we going to write? Fout. It's very suggestive. Okay. Oh wait, no, we can't do that. Let me call this output file. Okay. No, there's one subtle thing I forgot. I'm confused. Going to confuse you. Output file. We want to pass this int a onto the stream object, which is called fout. I'm sorry. That's why I was doing it this way. Okay. Does this kind of make sense? So we're calling operator less than on the class object, and what is that class object doing with this operator? It's just passing it on to the file stream or the fstream object for which it contains. Okay? So that's all our class object is doing in terms of the operator less than. Whatever we get told to output to the file, we just want to pass that parameter along to the fstream object which it contains internally. Okay? So this way, everything is contained within a class, and you don't have to worry about f.close, fopen, checking if the file exists, things like that. Let's see, what did I do wrong? Cannot convert from... Oh, oops. I don't want to return that. I need to return output file. OK. Normally, you return the stream itself, and then... Oh, yeah. There's one subtle thing. You can't do endl in this fashion. Sorry. OK, so let's run this. And now let's take a look at our file. Table squared data. There's all the table squared data. OK? So I can't put in return carriages. Endl is actually not an object. It's actually a function. So, but here's what I can do. How about this? Does this seem like a reasonable alternative? If I told you you can't cout or fout endl, you do that. So how would we make this work? We would take this, and what would we do? Instead of having it with an int, we'd have it with a string. Okay? String or string reference or const string reference? Let's do a const string reference. Yeah. Okay. We go down here. And again, all we're going to do is pass along this string that we're supposed to be outputting to the file. We're just going to pass it along to the file stream object inside. Okay. Now let's run it again. And there's our nicely formatted file. Okay. Now, what did you notice about, did it tell me I was overwriting a currently defined file? No. It will just, by default, it will automatically overwrite whatever file you have in that contents. You can seriously mess up your computer by doing this. Okay? So just be careful. Make sure that I've written code and I've run code where I forgot to save a calculation that ran all night long. We all do it at least once. So you just get in the habit of being very careful. If you're reading and writing to files, by default, when you write to a file, if it doesn't exist, it creates it. If it already exists, it overwrites it. No warnings, no telling you it's doing that, it just does it. Okay? So that's my warning with reading and writing files. When you write to a file, it will just create it if it's not there, or it will overwrite it if there is something there. Question?
So when you mean overwriting, does that mean like create a new file with the exact same name as the old one, everything in it is completely gone, or only what you're writing over?
Okay, so the question is about how the computer actually overwrites a file. The answer is that it depends on the operating system. My understanding of what happens is it just releases hold on the location where that other file was originally, creates a new location, and then starts writing there. So this is where the data people can come along if you've you deleted all the files on your computer, and you're like, help, I deleted all the files on my computer. Can I get them back? And they're like, well, maybe. And the maybe is because when you delete a file, it doesn't always go in and set all the bits to 0. It just rearranges indices or indexes. If it was indexing a file here, chances are the file's actually still there. All the data's still there. It's just there's no way to get to that data. And so those sorts of techniques can go in and find how it was organized previously and then try and extract all the data from there. Yeah. Typically as well, if you stored a certain file type, like a PowerPoint, there's a certain amount of header information and there's a format for that header information. So if you just are looking at ones and zeros and whatnot, you can actually look at the various patterns and try and detect this was a file of type PowerPoint. And it should end with this stream of kind of characters or ones and zeros, and you can piece it together. But yeah, in general, it will overwrite it. There's no easy way to get it back. Yeah. Okay. We can also overload operator greater than to cin values one at a time from a file. Okay, so let's go back to our input file, read from file. And like we saw before, let's make a friend read from file reference operator greater than. And we're going to do the same thing. So we're going to have a read from file reference, and we're going to read, say, an int from it. Okay? And what is this going to do? This is just going to do the exact same thing, which is it's just going to pass along the input argument to the internal fstream object. Okay, so we're going to take input file dot fn, and we're just going to read in a. Is that how it works? Yeah, we're going to read into a. But of course, not by value, by reference. Okay. Then we're going to return input file. Okay, so then a is going to get stored with the value from the file. So what is that? Inaccessible. I thought I made this. Oh yeah, so I didn't make this a reference. Once I make this a reference, it will detect it. Okay, ready? And now what we do is we go here. And now instead of getting one row at a time, for example, let's do the following. Let's create an int temp equals 0. And instead of doing all this stuff, check this out. While file temp. Okay, so remember you can write things like while cin greater than temp or whatever. We're going to do the exact same thing using our read from file objects. So while we're still able to grab something from the file, we're going to do v.pushback temp. We're going to grab the value. And then at the end, we're going to print out the values. Well, and then at the end, we're going to just square all the values in there. Well, let's just leave out the file output for a moment. Okay? So then we can do things like just print them all out. Must be convertible to bool. Yeah. Okay, so you know how with cin you can do while cin, and it'll actually, as long as there's valid text from the, it'll work. So it cannot convert it to bool. So let's throw in an operator bool function, and this will return. Read from file stuff. Okay. Operator bool. This is a read from file operator bool. Oh, we're almost done. Okay. And then we're going to return fin.fail. Okay? So we're going to just return the fail state of the stream object itself. And look at that. Now it compiles. Now let's go here and let's run this. Press any key to continue. Oh, yeah. Good one. Not fail. Yes, there we go. Okay? So by using a combination of resource acquisition as initialization, or in other words, resource management by putting a resource, creating it in the constructor, deleting it or calling close, as in the case with files, in the destructor, and by overloading various functions and in particular various operators, we can create an interface for reading and writing to and from files which is robust, clean, and looks exactly the same way as if it was coming from cin and cout. Okay? That's the idea. Are there any questions?